Hello, students. Today we are going to be looking at a problem here that is with multiplying decimal by a whole number with exponents. So the first thing that we need to do is take a look at the actual exponent and try to figure out what that means. Okay, so the exponent is this actual little number there. Sometimes it can be a 3, it can be a 4, it can be a 5, but all it means is that you are getting that many copies of that number. So for example, it would look like this. If I would actually move this to the side here, and if I were to rewrite this, and we would only focus on this right here in red, then that means that there are 2 copies of that number, which is 10. So it would look like this. 10 times 10. 1 copy, 2 copies. And it goes with the 2. So let's say we have something a little different. Let's say we have 10 to the 4th power, like that. That means we would have to have 4 copies of that 10 that would now look like this. That's 1, 2, 3, 4. You would have to multiply 10 times 10, which would be 100, times 10, and then times 10. Now that we have the exponent squared away, let's move forward with the solving of the decimal times an exponent. Okay, so let's start off with this part right here. Okay, so we know that 10 to the 2nd power means that we actually have to do 10 times 10. And we actually have to solve it. Okay, I saw that there are 2 copies of it, so I went ahead and did 10 twice, which would give me the answer of 100. Okay, I'm going to go ahead and rewrite my number here. So we have 6 and 32 hundredths times 100, because I went ahead and solved with my exponent here. Okay, so now this right here is our problem. It's 6 and 32 hundredths times 100. Now from here, all we have to do is multiply normally using the algorithm. Okay, so I'm going to go ahead and rewrite my problem one more time. And because I am multiplying a decimal times a whole number, I no longer have to line up my decimals. That's only for addition and subtraction of decimals. With the multiplication of a decimal and a whole number, I simply have to line up the numbers. So I will go ahead and do that. Lining up my numbers for the standard algorithm. So now that we are here, I'm going to go ahead, before I even start solving this part, I will count how many place values are behind the decimal for both numbers. How many place values are behind the decimal for both? Okay, so if I look at my first one, which is 6 32/100ths, here is my decimal, and I can see that there is 1, 2 place values. Now on this number down here, 100, the decimal belongs here, but there are no place values behind the decimal, which then now I know that 2 is the number that I have to write because there are only 2 place values behind the decimal. So now that I have counted, I can multiply my standard algorithm. I could even pretend that that decimal is not there so that it can make this multiplication process maybe a tad bit easier for you. Okay, so let's multiply. Let's start with the ones. 2 times 0 is 0. 0 times 3 is 0. 0 times 6 is 0. I've worked with my ones place. Now I'm going to use my place value holder, add the 0. Now work with the other 0. 0 times 2 is 0. 0 times 3 is 0. 0 times 6 is 0. Okay, now I'm moving into my hundreds, which would require me to do 2 place value holders. Now I do 1 times 2, which is 2, 1 times 3, which is 3, and 1 times 6, which is 6. I then add my partial products. Start with the 1, 0 plus 0 plus 0 is 0. 0 plus 0 plus 0. Next is 0 plus 0 plus 2. 0 plus 3 is 3. And of course 6. Okay, so I have here 63,200. The thing is, I can't forget about this very important step that I did at the very beginning. It states that I had a 2, which now means that I'm going to move over to the end of this number that I have here. And from right to left, I will make 2 jumps because that is what I wrote down earlier. So 1, 2 jumps, making this number and the final answer 632, which can also be seen as this. These are both equivalent to each other. Final answer is 632.